Our body is a collection of different systems. We have the nervous system, the digestive system, the reproductive system, and so on. These systems perform necessary functions to keep us alive. However, our bodies are also made up of many different elements. Each of these elements is a chemical substance that cannot be broken down into simpler substances by ordinary chemical means. 99.9% of the mass of our bodies is made up of just 6 elements: oxygen, carbon, hydrogen, nitrogen, calcium, and phosphorus. But where did these elements come from? Where did all these elements that make up our body originate? Are we truly what we eat? Well, some of us are. As we humans study the composition of our body, we also tend to study the composition of other objects. Back in 1969, Alan Bean, an astronaut who flew on Apollo 12, took this photograph of the surface of the moon during the second moon landing mission. In 1976, he painted a picture based on this photograph. It shows an astronaut standing on the moon with the Earth in the background. It's a very famous painting. Bean described the painting as an allegory of where we came from, where we are, and where we're going. In other words, he saw the painting as symbolic of the origins of humanity, our current situation, and our future ahead of us. Is this also true for the origin of the elements that make up our body? Where did they all come from? The theory that we are all made of stardust has been around for decades. But recently, researchers at the University of Göttingen in Germany have conducted new research on where the elements that make up our body actually originated from. Researchers wanted to find out whether the elements in our body formed inside or outside of stars. Their results show that most of the elements that make up our body were produced inside stars that exploded as supernovae. Lead author Dr. Daniel Morales Garcia said, "We analyzed the yields of supernova explosions of different types and compared them to the observed abundances of the elements in meteorites. We found that only a small fraction of the elements in meteorites can be explained by the material ejected during the death throes of a star. On the other hand, nearly all of the iron group elements such as iron, nickel, and zinc originated in such supernova explosions. So where did the remaining elements come from?" Dr. Garcia explains, "The majority of the light elements such as oxygen, carbon, sodium, and magnesium were produced in the interior of stars that collapsed without exploding, so-called white dwarfs, slowly releasing their material into the surrounding interstellar matter over a period of billions of years. The low temperature of this material enabled the lightest elements such as hydrogen, helium, and lithium to escape into space, whereas heavier elements remained bound to the white dwarf. The boundary between these two processes is situated around the iron group elements. Iron is thus the key element for understanding where exactly these processes occur. Interestingly, the researchers also found that several elements that are not normally considered to be life-building blocks also mostly originated in the interiors of stars. This includes elements such as neon, sodium, aluminum, chlorine, and argon. While these elements do not play a major role in biochemistry, they are still important because they are present on Earth. Dr. Garcia says, "It is amazing to see how the abundance pattern of elements in meteorites fits to the origin sites predicted by our models. This gives us confidence that we are indeed reading the correct history of our elements from the meteorite record." So now you know where most of the elements that make up our body originated from. But what about the big one? Gold. Like many other precious metals, gold is rare in the universe. Gold is one of the least abundant elements on Earth, making up only 4 parts per billion of the Earth's crust. But it's slightly more abundant on the surface of asteroids, ranging from 1 to 100 parts per billion. How did gold get here? In 2012, researchers presented evidence that gold and other elements such as platinum, uranium, and thorium were produced in the merger of 2 neutron stars. two highly magnetized, rapidly spinning neutron stars spiraled around each other before merging. During this process, the magnetic fields of the two neutron stars generated enormous energy that caused a large amount of protons and neutrons to slam into one another, forming a large amount of heavy elements in the process. One of these elements is gold. This research was published in the journal Physical Review Letters. The authors of the papers say that nuclear astrophysicists have long suspected that the merger of two neutron stars could explain the origin of gold and other heavy elements. To confirm this suspicion, they developed a three-dimensional computer simulation of the merger process. The researchers say that their model suggests that the R process responsible for producing these elements occurred in the extreme conditions of a neutron star merger and supports observations that a significant fraction of the gold in the solar system was produced in such events. But this is not the only theory about the origin of gold. Another hypothesis is that gold and other heavy elements are produced in the explosive thermonuclear reactions of a single, highly magnetized massive star, similar to a supernova. Scientists used data from NASA, Chandra X-ray Observatory, and the European Space Agency, XMM Newton, to examine Cassiopeia A. This is the remnant of a supernova explosion, which occurred about 340 light-years away from Earth. They discovered a surprisingly large amount of iron in this supernova remnant. This suggests that some of the iron in the solar system may have come from this explosion. Now scientists are trying to find out whether the same thing could happen with gold. Researchers say that while they haven't figured out how exactly gold is produced in these types of events, they know that it does happen. So, where did the gold in our jewelry come from? Our guess is that it might have come from a neutron star merger or a supernova explosion. However, it is unlikely that the gold in our jewelry contains gold from a particular star. Scientists don't think that the remains of a single star could explain the amount of gold that exists in the solar system. Instead, the gold in our jewelry might contain material from hundreds or even thousands of different stars. You see, our solar system formed in a molecular cloud that extended throughout the spiral arm of the galaxy. Most of the material in this cloud was hydrogen and helium, which are produced in the core of stars. As the cloud collapsed into a disk, heavier elements produced in the core of ancient stars settled at the bottom of the future planet core. This material never mixed with the outer layers of the planet, which were largely made of hydrogen and helium captured from the surrounding nebula. This is why the Earth's core contains a lot of heavy elements, including gold, while the rest of the Earth is largely made of lighter elements. What do you think? Do you feel more connected with the universe after hearing where the elements that make up our body originated from? Let us know in the comments below. And don't forget to subscribe for more videos of Cosmos in a Minute.